Hopefully, we are live. So, welcome to the first ever online GDG Tampere meetup. And this is my house. I don't usually let people in like this, but because of the recent circumstances, which is coronavirus, we had to drop the meetup part from the meetup. Yeah. So my name is Tero Vepsäläinen, and I'm the site lead for Polar Squad on Tampere, also a DevOps consultant, and also double shifting here as one of the meetup organizers for GDG Tampere. Like I said, this is the first time that we are trying this online format. Hopefully it will be an awesome thing, which I trust totally that it will be, and will be hailed as the community heroes from here on. During the meetup, please remember to wash your hands correctly and do not sneeze at familiar people or strangers. It's bad karma, and you know the drift. There should be a chat maybe there or there or there or there that you can use during this meetup to ask questions from our presenters. There was also a cat at any time, and we'll try to get those questions to them so they'll answer when they see fit, but possibly at the end of the whole event. So I guess that was all from like the organizer's side. Let's have fun on this. And as I'm double tagging, I will do also the Polar Squad side. So let's do some slides. That was a graceful transition to the slides. It didn't take even 5 seconds. So we are Polar Squad. If there's one thing you should take home from this presentation, is that we are the best DevOps company, according to us. But just remember this, everything else will be just something that will support this claim. We believe this is our values, our people, empathy, and ambition. And basically, our people come first. We've been around for a little over 2 years. Apparently, our employees and our customers are quite happy. And you can find out that we could consider ourselves quite a senior bunch, because it's almost 14 years of average IT area experience. We have 3 offices, one in Berlin, which is Germany, and 2 in Finland, Tampere and Helsinki. We amount around 40-something consultants, the largest site being in Helsinki. What we do is DevOps, site reliability engineering, data ops, DevSecOps, DevOps assessments or technical assessments, workshops and training, and also coaching. And what technologies we do? Well, the big trio, Amazon Web Services, Google Cloud, and Microsoft Azure. And also we deal heavily with Kubernetes. I would say that most of our projects, over half. Also, Terraform and OpenShift are another tools that we keep involving ourselves with. That's the treasure of live stream. That, my dear people, is a cat. And that's the wrap for me. Have a pleasant meetup stream, and please comment if you have something to comment.
So should I start presenting? Count down to 5 for like 30. So, hello everyone. Let's hope this is live. Thank you, Tero, for the opening words. My name is Anton, and I'm here to tell you a little bit about Stackdriver. The reason for the name of this talk is due to me asking this question a lot lately. Seems like a lot of people dislike Stackdriver, but no one really has a good explanation why. Maybe the UI is a bit confusing, but other than that, I feel Stackdriver can be the right tool to build observability into your applications, especially if your application runs heavily on Google Cloud Platform. On Stackdriver is called Cloud Operations Suite now, but that changed just a few weeks ago, so I kept Stackdriver in the name of the talk. So what's going to happen is that first I'll introduce myself, then I'll say a few words about my company. After that, I'll introduce you Cloud Operations and the tools within the suite. Then we have a short live demo. Hopefully everything goes as planned. And finally, I'll give a few key takeaways from this talk. And I'll take questions in the end, or I'll try to answer them in the chat after the talk, if we still have time left. So, who am I? My name is Anton Ahlroth. Right now I'm based in Helsinki, Finland. I work in the software industry for over 8 years. I work as a DevOps consultant at Polar Squad. So my background is in infrastructure, but I've tried on many different roles within the industry. I kind of consider myself a tech generalist, and I'm also a Google certified professional cloud architect. You can check out my LinkedIn or GitHub. Links are below. And that's about me. So Polar Squad, Tero gave excellent presentation about Polar Squad, so you should check it out. But I'll recap fast. So Polar Squad, it's the best DevOps company, at least according to us. And honestly, I'm amazed by how talented my colleagues are every day. We do DevOps consulting. This includes SRE, data ops, trainings, workshops, etc. Honestly, anything related to infrastructure. If you need help with any of the topics mentioned earlier, feel free to contact us. Check out our website, polarsquad.com, for details. And that's it. So let's get on the topic of cloud operations. It's a suite of tools to build observability into your applications. It was previously known as Stackdriver Suite, and Stackdriver was acquired by Google in 2014, and it has been generally available since 2016 on Google Cloud Platform. All the services are fully managed, so the biggest tools are cloud logging and cloud monitoring, and then there are other stuff, tracing, errors, debugger, and profiler. So cloud logging is obviously for logs. It allows you to store, search, and analyze your logs. Cloud monitoring lets you observe your application. It stores metrics, allows you to build charts and dashboards, create alerts, and uptime checks. I'll give more detailed overview of cloud logging and monitoring afterwards. But for the other stuff, I'll briefly go over them. Trace is for finding performance bottlenecks. You can use it with App Engine, load balancers, and apps with the Stackdriver Trace SDK. Error reporting is a real-time error monitoring tool. It's built into App Engine and functions. Then we have the debugger, which lets you debug applications and inspect the application state, which are automatically enabled in App Engine standard. And it can also be installed on non-GCP resources. Then we have a profiler, which is for analyzing CPU and memory uses of your applications. It integrates with source codes, so it can be a helpful tool. I would go into details with the other services, but for example, if you use App Engine, you should take a look at them. They can be really handy. This is Google's definition of cloud logging. Like I said, cloud logging lets you store, search, and analyze your logs. I feel that you can import custom logs from basically anywhere, as the service has an API that allows you to ingest any custom log data from any source. Logs are stored for 30 days. Audit logs are stored for 400 days. But if you need longer retention time, you can always export data out of cloud logging using sinks. You can use sinks for other purposes as well, like if you want to do analytics or stream the logs to another applications. There are currently 3 sinks supported at the moment, which are the Cloud Storage, BigQuery, and PubSub. And you can use PubSub to integrate into basically anything. There are a bunch of different types of logs. For example, audit logs for auditing, platform logs from GCP services, and custom logs like your applications logs. Using cloud logging is free, but storing logs will incur a price, but it's relatively cheap. And I think you get like 50 gigabytes per month for free anyway. Audit logs, access transparency logs, and excluded logs are free, of course. Access transparency logs are log events when Google staff accesses your resources. Like, I don't know, if you have a support ticket open, they just need to access some of your resources, and that leaves some access transparency log. You can also exclude logs, but you need to create a filter, and you can have up to 50 exclusion queries in a project. So you need to think about how you need to exclude your logs if you need to do that. You can also disable all logs if you don't want them at all. You can create log-based metrics and visualize based on your logs. You can also create alerts from those metrics in the cloud monitoring port. There's a new UI for cloud logging incoming by Google. It's in preview right now. It looks nicer, but unfortunately it lacks a lot of features that the old UI still has, but they are working on it. So maybe in a couple months we have a completely new and nicer UI. Then we have the cloud monitoring, and again, this is Google's definition. I feel it's a tool that provides the visibility into your application. So it's basically a time series database with visualization and alerting capabilities, kind of like Kibana or something like this. In addition of having GCP metrics out of the box, cloud monitoring allows you to export custom metrics. For example, you could do Kubernetes output auto-scaling using custom metrics, depending on your use case. There are a few ways of bringing custom metrics into cloud monitoring. For example, you could use Prometheus and scrape metrics from your Kubernetes cluster, which is hosted in Kubernetes Engine or Compute Engine. There's also a cloud monitoring API that you can use. It supports REST and gRPC. You can do other stuff with the API too. For example, manage your dashboards through the API, and you could programmatically duplicate dashboards between environments. So it lets you easily transition between, for example, if you have a test environment and production environment, you can copy the dashboard basically from test to production, etc. You could also, if you don't like the dashboards in cloud monitoring, you could use Grafana. Grafana ships with built-in support for Stackdriver. Basically, you just need to set up a data source in Grafana, and you need to jump through a few hoops to get it to work, like set up authentication from Grafana to GCP. But you can do that. So, yeah, that's about the presentation. So time for a demo. So a little disclaimer, I'm not a Stackdriver guru. I just used it in a few projects and wanted to show you how to get started with cloud operations. I'm going to demo live, so let's hope demo gods favor me today. I didn't sacrifice a ghost for them, so let's hope they're not angry. So I created this demo application to generate some logs for me. It's a classic 3-tier application. It runs on Kubernetes engine as it includes native integration with cloud monitoring and cloud logging. Without this, you would need to install monitoring and logging agents for other platforms to integrate into Stackdriver. The front end is written in Vue.js. It runs on Nginx on top of Google Kubernetes engine. Backend is written in Python using Fast API framework. And database is Postgres, which is hosted on Cloud SQL and GCP. Mainly I chose the technologies because I just want to try them out. There's no other reason for that. So the app looks like this. It's a simple loading application that lets you vote for your favorite 90s action movie hero. For example, you could just click the portrait and vote for your favorite actor. So let's get to the Stackdriver part. You get logging from this UI on Google Cloud Platform. There's operations, previously known as Stackdriver. And here we want to go to the logs. This is the new UI actually. It looks a bit neater and it has a nice query builder. It helps you with whatever things you need to find. You can also customize the layout a little bit if you want, but still, like a lot of features are still missing. So I'll use the classic log view.
Yeah.
So here you can search the logs. You can do pretty basic filtering here if you want to. You also have advanced filters where you can put whatever you want. We don't have any error logs here. We could also we can share the logs. We can copy the link and share it with our friends if we need to, or colleagues. We can also create log-based metrics. So if you would need to, I don't know, if you want to track errors, for example, we would create a metric. And for this, we need to make a filter at least. We want to use advanced filter. And we want to just find errors or anything below, like warning, for example. So this would show everything below warning, like critical and errors and whatever. And now we have a filter, And then we create a metric out of it. So let's call this, I don't know, demo app errors. This is, by the way, from the whole project. So everything happening in this project will be included because I didn't specify it. But we don't have anything else on this project than the demo application. Let's put some description. Type is actually counter. We create a metric. And now we have a metric that we can visualize. Let's create another one also. I want to find backend request. So we could do like I don't know. Just like a dirty way of getting the nginx, or actually the backend request count. So here we have all these logs, and now we have a filter, so we can save it as backend requests. So it's counter. Oh, actually, that's front end. We wanted back end. So let's go back and change that. So these are front end requests. So we could actually take both back end and front end requests. So these are API backend requests, and here are the front end requests. Let's just change the name to reflect this. Yes, now we have two metrics. We can explore this in the metrics explorer, which will go to the cloud monitoring part. But first I want to show you logs router. And this is where if you want to export logs, you would do it. For example, you would want to analyze some logs. I don't know. You can do the same filter here. You can basically do everything. And that's our filter. All logs. Sync name. Here are the different sync services. Custom destination is actually using PubSub, I believe, and some integration with PubSub. But as we want to do analytics, we will use BigQuery. We'll use partition tables. So basically, it will create a table per each day. So you could do some stuff like, I don't know, delete logs every 90 days or 1 year or whatever. We'll create a new BigQuery dataset. All right, we cannot use hyphens. And we can create our sync. Now it should work if everything goes as planned. Yes, it was successful, blah, blah, blah. Let's go to BigQuery. There probably aren't any logs yet, but it should, yeah, the table is empty right now, but the dataset is empty, there's no tables, but it should start generating logs for us once there are logs. You could use SQL to query this, and you could use, let's say, Data Studio to visualize your report. I don't know, in operational roles, you usually have to create like monthly, I don't know, uptime reports or whatever. You could automate this thing. But yeah, that's about it. Now we could actually visualize the metrics and create some dashboards and alerts. Let's see if I can find here. We could go directly from here to cloud monitoring. Didn't actually show us anything, I believe. Yeah, it will take a while to get some logs here. But yeah, this is our main view. It's not really clear, and I think this is the reason why many people don't like it. But here, for example, if you have alerts, it would create incidents here. What are open and acknowledged closed are hidden. There's resource dashboards. These are provided by Google. So, for example, this Kubernetes engine is the new one, where you can visualize your cluster. I don't know. You can see whatever is running on your cluster. There's our backend and front end. We're going to run one pod for our services. So this can be quite nice also. But we want to create our own dashboard. Let's call it demo application. And here we're going to add charts. There are tons of resources here you could use. These are all provided by Google. But we want to use the demo application things we just created. So let's do the request count. There's an advanced options like how often it is to run. There are view options. We could create a threshold if we want. I don't know, if there's one request per second. You could see if it crosses over that. And here we have it. We don't have any data right now. So we could actually create some load to the backend. Basically, this is just spam votes Ahlroth in our application here. So you can see we start to get more votes for Ahlroth. So hopefully we should see some data here in any minute now. Let's do another resource called the errors. This is kind of critical actually, or good to know like how many errors we have in our application or project. And here, like, I don't know. We don't actually even need well, let's put one. So we see something. Yeah, like I said, this is still empty. Now we see request coming in. And we actually have an error here, but yeah. And as these are log-based metrics, we should be able to go back to the logs from the UI, for example. If we see some errors here, we can, oh, wait, we can go back to the logs and see what's happening. I don't know why this thing comes up here, but yeah, we saw an error from Kubernetes Stackdriver integration. So, for example, if you have alerts configured from the dashboard, you can go straight back to the logs and do some digging if you need to. Yeah. Go back to our dashboard. Our request count is rising, it's below over 1. Here's Metric Explorer. It's kind of like a chart, and you can save a chart from this if you, I don't know, just click anything, and you can save a chart from here. Here we can configure alerting. We need to create an alert policy. We create a condition. I wish we could use the existing charts here, but I guess you still need to do this again. basically the same stuff. Then there are different methods to do this, but we put a threshold when threshold of 1 is above 1 for 1 minute. You can configure whatever value you want. It should create an alert. You can also create uptime checks and process health checks, but this is just a kind of like alert metric we want to do it right now. Now we have a condition, and when that condition is passed, we do a notification, and then we need to check the notification channel. You need to customize your notification channels if you want to use something else than the default ones. For example, we have the Google Cloud Console, which is, if you have the mobile application, you will have a notification or email by default. Nothing else is enabled, so you need to configure all of these stuff by yourself. So, for example, if you want PagerDuty or, I don't know, Slack or PubSub or whatever, you need to do it here. But for now, we just use the Google Cloud Console mobile. And this is my my phone. And you need to set it up also on the profile. So now we have an alert. And we can actually do some documentation here. If this error occurs, do something. You could watch the preview if you want, but we don't really care at this point. So now we have an error alert for the demo app errors. And as we see, it has not passed 1 per second, so it's not giving us an error. You can enable from the policies. It's the same you came here, or actually not. This is the overview. Let's create another one so we can actually see some incidents. Let's use the demo app backend requests. If we have one per second. Yes. Notification channel. Let's use the mobile app again. All right. Computers are hard sometimes. Yes, and oh damn, it fixed it automatically. Yeah, we should see an error pretty soon. It actually starts counting from right now, so it doesn't take into account the older nodes. But as we have the spam voting still going on, Arnold going strong, 4,000 volts. We should see an alert pretty soon. I could actually show you some older incidents, or we just see actually resolve the incidents here. And we have a log events here. Whatever. Let's go back there in a minute. Then we have uptime checks. So basically, it's kind of like if you know Pingdom or status cakes or whatever. It's kind of like built-in feature. So you have a name, you have a check type, you have a, I don't know, you could use app engine or instance or URL, you put a host name, path, whatever, how often you check, and you can log those. There are some additional features if you need to, I don't know, configure some headers or region or encrypted headers or whatever, and you test it out. I'm not going to do this, but it's nice to know that you have this, because oftentimes you want to have some kind of a health checks for your systems. Here you can group your resources, and here are some settings. You can see like your usage and whatever. Yeah, if we have an incident. Still no incidents. It's curious. We don't have enough requests here. maybe I used the wrong one. It could be actually because of that. Let's try again. Demo app requests. Demo app requests. Okay, here we have. Yes, I used the wrong one. It was the front end one I used. Yes, then we go to the notification channel. Got the mobile thingy again. Help me. And now we see the threshold is actually over, so we should get an incident right away. Let's actually put this down. We should see alert in a minute or so. Where's my alert? There's my instance in Cloud SQL. Not much happening here. Barely running. It's a quite simple database I have here. It's just one table basically. I don't get it. Why isn't it firing? Should fire. Oh well, anyway, it probably just takes like 5 minutes or something to start firing. I guess that's pretty much about the basic usage of cloud operations. So, and I'll try to show you the alert afterwards, but let's go to key takeaways. So, Stackdriver is now called Cloud Operations Suite. It might not be as cool as sliced bread, but it'll get the job done, especially if you use a lot of GCP services. It lets you build observability into your applications, and you can easily export or import data into cloud operations. They say Stackdriver is full stack monitoring for GCP and AWS, but you can basically get data from any location with some workarounds. For example, using the Workplane service or the APIs. Although if you have multi-cloud setup, it might be better to use something else. But for a small, let's say only GCP projects, Stackdriver it works. There's no problems with it. It can be a little bit confusing at start, but once you get the hang of it, it's okay. Stackdriver, it integrates easily with other tools. For example, you can visualize metrics using Grafana. There's a built-in support for that. So I want to encourage you guys to give Stackdriver another look, especially if your application relies heavily on GCP. So that's all from me. Do you have any questions? I can also try to answer any questions in the chat too. Later after this. I don't know if you have any time left. Let's see if we still have the alert. Yes, now we have an incident here. And here we have a documentation if we have. I can acknowledge this thingy. And now that I stop the request, it should automatically resolve itself. But yeah, I guess if you don't have any questions, feel free to leave them on the chat. I might look them up later. Thank you all for your time, and have a nice day.
Okay, well, thank you, Tero and Anton, and hi everyone else, and welcome to the meetup from my side as well. Or maybe you could call this like a webinar now, but let's not let that bother us. I hope you're all well and fine out there, and thanks everyone for joining today. Lauri Piispanen, and today we're going to be talking about Kubernetes operators. In the photo right there, and obviously I look very sharp when I'm working from home. I'm not wearing any sweatpants or anything, right? Well, anyhow, I'm from a company called Reaktor, and we do software consulting. And as would be the trend, I do a lot of cloud gigs nowadays. Now, obviously, cloud has been around for over a decade now, but it really feels like in the past 5 or so years, it has really started to take off with the whole DevOps movement. And there's a lot of new tools and paradigms that drastically alter the landscape. I can say that containers have really changed the game lately. Looking back at things, I think we've come quite far already. You know, way back when cloud computing was just a brand new thing, we would spin off these compute instances, these little virtual servers that you could just start with a press of a button, and then you could just kill them when you didn't need them anymore. And that was just like groundbreaking, at least to me. But you know, while that was far more flexible than having these big iron servers, you still needed to patch the OSs and install libraries and stuff. And it wasn't really had on your development laptop. So you'd get these consistency issues when things didn't match, and you know, the classic works on my machine. And if you weren't careful, you'd get some drift on the instances having different versions of stuff and so on. Then containers came around, and they really helped with all that. So we started putting our software in containers, and that was quite nice. You got this little deployment unit that you could just take and say, run this, and it contained almost everything it needed. And if you needed to update stuff, you'd just build a new container and deploy that. But then when we started to get a lot of these little containers, we needed some way to manage them, your Docker swarms and other solutions. But you know, like if you've not been under a rock for the past couple of years, everyone's been pretty much just converging on Kubernetes. And you know, it's nice. I mean, it's given us consultants a lot of new work. Now, I'm joking, of course. I mean, for its intended purpose, it's actually a pretty nice piece of kit. You know, you can set up this cluster and you can manage it completely. You can let people deploy their workloads and help them make sure that they get handled reliably. You can run your workloads, you can update them, inspect them, you can get their status, you can see how they're doing, you can see if something's wrong with them, or if there is something wrong with them, you can tweak their settings and overall just, you know, control their life cycle from a distance. So it's nice. And if you happen to get a call from an angry CEO in the middle of the night saying that your application is broken right now, you can just, you know, go in and restart it or something. But then again, why would you want to wake up in the middle of the night just to give your application a little kick? Would it not be better if the application could just, kick itself? Time you just go in and look at a couple of things, you find out that, yeah, it's broken all right. And then you do some appropriate corrective action, and that brings it back online. And even if it's running smoothly, you've got things like security patches, database backups, and all types of maintenance procedures, which quite often are pretty repetitive. And you can almost build a checklist that basically you just run through every single time you need to perform them. And actually, this train of thought isn't really new at all. It's pretty much as soon as we started having any kind of complex systems and machines, even before computers, people wanted them to work reliably on their own. A quick sidestep and briefly discuss the topic of control theory. Control theory is the whole field of engineering on its own, and we could talk about it in detail for ages. But the gist of it is that it's about the control of continuously operating systems in different processes and machines, and it's used to build for these systems. Now, obviously, the ideal goal is that you would build such controllers that they work in a stable manner and they don't have any delays or overshoots, and they just keep running the system. So, take, for example, the cruise control in your car, if you have one. Or better yet, let's take a modern adaptive cruise control, the type that tries and keep your car moving at the speed you specified, while also taking care of that you don't plow into any cars that are in front of you, which is pretty useful. So you got a bunch of sensors in there, and they tell the controller how fast the car is going right now, and also what's the distance to the car in front of you. In theory, this would be what we call process variables. And then you've also got these other things called reference values, and in this case, that would be the speed that you set your cruise control to, distance to any cars you want to keep in front of you. Now, so what the controller will do in this case, it's going to take a look at these inputs, your speed and the distance, and it'll compare them with the error between the reference value, the speed that you want to go, and the desired minimum distance. And then it'll decide some kind of control action. So it's either going to hit the gas, or it's going to press the brakes, or unless you want to be jerking forward and backward all the time, it might just choose to do nothing at all. So obviously, like real cruise controls are a little bit more complex than this, controllers and whatnot. But this is basically the gist of how they work. Speed, is it lower than what the user wanted? Okay, so let's take a look at our distance. If we're far enough, we can safely hit the gas and go faster. If the speed is higher than what we wanted and we're far enough from any other cars, we do nothing at all, so the speed's just going to slow down gradually. And if we're too close to any other cars, we might want to hit the brakes. Oh, what's a cruise control got to do with Kubernetes then? Well, actually, it turns out that when we're talking about automating the control of complex systems, we are kind of smack in the middle of control theory. Notice that there's a bunch of different controllers in your Kubernetes clusters already. What they are doing is exactly what the controllers do in control theory. Specific things in the cluster as their inputs. They compare these to the configured reference values that very often you've put in. They go and they poke around at some controls and try to make these values get closer to one another. So to illustrate what I'm talking about, let's take an example. Let's look at something that's quite ubiquitous. Probably all used replica sets at some point, right? So the replica set, surprise, surprise, has a controller of its own. Controller is actually pretty simple. You can go into the Kubernetes source code and you can take a look at what it does. And for your convenience, so you don't have to go there and look at it right now, I've taken the best parts of it on this slide. We have a run function that's very simple. It basically just starts off a bunch of workers and that periodically execute a worker function. Now, the worker function, again, is just a very simple loop to pull off any items that might be in its work queue. And then eventually, for them, it'll call a function called manage replicas. So now we're getting right into the middle of the control loop. Replicas is the part where we're actually deciding on the action that our controller is going to do. And replica sets manage replicas control function. I mean, all it does is it looks at the number of your currently executing pods, and it compares that to the desired number of pods. You can see that on the first row of the manage replicas. There's a difference between the number of pods and the number of pods that are running. And then if there's not enough pods running, it'll just create more of them. And if there's too many pods running, it'll just delete some of them. And these creates and deletes are just the only thing that's there in addition is a burst factor. So you don't create like a bunch of ones, but only a smaller number. Once all this is done, the controller will just sit down and wait until the expected number of operations have taken place, the expected numbers of pods has come up, or have been destroyed all over again, and runs the control loop. So you can see that Kubernetes actually leverages control theory quite extensively, and there's a number of different controllers that are in the Kubernetes control plane. You've got your deployments, you've got stateful sets, daemon sets, etc., etc. And at any given time, these controllers are actually sensing around your inputs, your state of the cluster, and then they're performing control actions as they deem necessary. And because of these control loops are happening all the time, this documentation even says that the cluster could be in a constant state of change, and potentially it might never reach a stable state. And this is fine, as Meme says, because as long as the controllers are running, that are useful, do you really even care if the state stabilizes or not, right? I mean, they're doing things that are constantly transitioning the cluster to a better state. So let's have them do that. All right, so we've been talking about control theory and controllers for now, but if I'm not completely wrong, I think the topic of the talk was operators and not controllers. So what are operators and how are they different from controllers? Your operators are basically controllers. A couple of additional things with them. Controllers are operators, but all operators use the control pattern. And the term was coined by the CoreOS folks, who say that an operator is a method of packaging, deploying, and managing a Kubernetes application. Now, a Kubernetes application is an application that is both deployed on Kubernetes and managed using the Kubernetes APIs and kubectl tooling. A bit more concise wording might put it that an operator is control pattern plus API extension plus single app focus. So the main point of operators is to encapsulate operational knowledge on how to run a specific application. Now, the basic tasks obviously are how to install the application and how to update it, but ultimately they can go on much further and can include things like how to manage the application lifecycle, how to take backups, how to do failure recovery, how to scale the application or do alerting or monitoring, etc., etc. Expose all this functionality in a Kubernetes native manner to the end user via API extensions. I think it'll become a bit clearer if we actually take a look at an actual operator at this point. And we'll do that with the help of operator framework and SDK that are built on the operator pattern. And they help you develop and run operators in your clusters. So, operatorhub.io between Red Hat, Google, Amazon, and Microsoft. And you can think of Operator Hub as kind of like NPM for operators. And you can see that there's a couple of familiar ones like Akka and Spark and many others over there. You can just go ahead and see if there's an operator for an application that you like, and you just go ahead and install it quite simply. Install one. So I've got Minikube running here on my laptop. And what I've already done is I've installed a component called the Operator Lifecycle Manager. You can see that I've got a bunch of stuff already running in the OLM space. So there's instructions on Operator Hub how you install the OLM and the Operator Lifecycle Manager. So I'm not going to go through it in this scenario. Suffice to say, it was a couple of kubectl apply operations with URLs pointing to GitHub. We'll talk about that later. I've got the OLM installed, I can just go ahead and install an operator. And well, I picked, surprise, surprise, Postgres, because it's my favorite relational database. So let's install Postgres operator from Operator Hub. There's a couple of them already. And we're going to pick one that's built by the good folks at Zalando. So you can see here that I added a subscription to Postgres operator to my cluster. That's it. That's a very simple manifest. And you can see that after a few minutes, once the lifecycle manager picks up the subscription, you can see that it's created a Postgres operator deployment in my operators namespace. And finally, now that you've got the operator installed, you basically can go ahead and deploy a Postgres instance. So there's a couple of different templates that Zalando nicely provides, and I took a very simple one, a sort of minimal template. You can see that here, basically a minimal cluster with 2 instances, a database, and our configuration options that you could tweak, you could set up, things like backups, version updates, etc., etc. You take this simple manifest and you apply it to the cluster and wait a couple of minutes, or even not that long. And what happens is the operator will spot that manifest, and it'll go and create a bunch of different pods for us. It actually creates PostgreSQL instance for us. Now that's the command you can see over there is maybe a bit unsightly, but all it's basically doing is grabbing a bunch of different things from the cluster and then feeding them to PSQL, and we get a connection, and you see that we've got tables running in there. So presto, just a few commands, and only executing some completely unknown code from the internet, we have a full-blown PostgreSQL master replica configuration. The developer experience is actually not unlike installing dependencies with NPM, if you've ever done that. And that's actually quite scary if you start to think about it, just installing very random code from the internet. But I think it's not a good thing if we don't think about it too much right now, because the next step would then obviously be to build something ourselves. Go back to the operator SDK from the operator framework and show you how to install that. You can go to the website and install that. There's a bunch of different options you could use. Operator framework is just one way of building operators. There's a couple of them, so you've got your choice. But the SDK is quite simple. You get a nice command line tool where you can just start your new project, and it'll create a nice scaffolding for you. It'll offer all kinds of tools to run and test and publish your operators if you want to do that. So it's point, I'd say it's quite nice. We are now going to build an actual quite tiny operator. And just to make things interesting, we're going to build it in Go, because that's much more interesting than writing a bunch of YAML files, although we do a lot anyway. The operator framework also offers you a bunch of different starting points. Like if you're using Helm, you can take your Helm charts and you can wrap them into a custom operator quite easily. It's a fully featured operator that way, as you do when you take and actually dig into code. But it's a nice way to get started writing your own operators. You get something that installs and updates quite easily. It also supports Ansible operators. Go and write things in Go, or I think it supports many other languages as well. What we're going to do is we're going to take a page off of Netflix's book, build our very own little chaos monkey that's going to go around and randomly shut down pods in our cluster, and hopefully they will come back again. And if chaos engineering is a new concept to you, it basically means that since you want to build a resilient application and system, you actually introduce some intentional chaos. You basically introduce some havoc and destruction in your environment, so that it's like it's like breaking all the time, so that breaking it does not come as a surprise to you. You're prepared for things breaking down or network latencies or whatnot. And that way you can actually be confident that if these things happen in production, you've already prepared for them in advance, and you've built a system that automatically heals itself and can return to a working state. This is like the usual, if things hurt, you should do them more. And if it hurts you that your servers are dying, then you should just kill your servers more. You learn how to handle those things. Now, obviously, we're not going to build a fully fledged chaos framework in this short meetup talk. It's going to be a very simple operator, and if this is something that you think that you want to run in your environment, I do recommend you go and check out a project called Litmus. It's got a lot more ways you can introduce a little bit of chaos into your cluster, and it's also got some very good functions to also make sure that your pods and your deployments and your services come back up again. But maybe this one little feature is just perfect for learning purposes. So let's look at my Visual Studio Code, which I use for coding my Go projects. A tiny little basic project created here. This is all, as I mentioned, basically a scaffolding. SDK pretty much generated all of this for me. And apart from just creating the project, the other thing we did with the SDK is we added a Kubernetes API and also introduced a custom resource called Chaos Monkey. Now, that's the part where we're talking that we're building things that are Kubernetes native. There's commands in the operator SDK that do all of that for you, and they create a bunch of different files for us as well. Now, the important ones at this time would be the Chaos Monkey types.go, which you can see highlighted over here. Now, this file contains our schemas for the specs, the specifications, and the status of our little Chaos Monkey. Back to when we talked about control theory, you'll probably remember that these are the desired and observed states that we were talking about earlier. Now, because this is a very simple operator, we don't have a lot of state we're trying to aim for. We basically only have the interval that we add. So we just specify the interval parameter in our spec. And we've also specified a last runtime field in our status so that we know when was the last time we killed a pod, so we don't do it too often or too rarely. So that's the basic underpinnings of our operator. And then we move on to what's the real heart of our operator. And as it was with the replica set as well, we've got a little reconciliation loop going on over here. Now that's the part where our controller gets woken up whenever all kinds of interesting things happen. This would be equal to the function that was running in the worker functions in a replica set, where we go and take a look at the world around us, and then figure out, based on those inputs, we decide what we're going to do next. And we might decide that we're not going to do anything at all. Part of the operators paradigm. Reconciliation loop in this case looks like we'll do the following. It'll check to see if we've had enough time passed so that we can kill a pod. And if that has happened, we go and find a pod for us to kill. And if we find a pod for us to kill, update our internal status and kill the pod, and then we go back to sleep, only to be woken up later. Now, what's not displayed here is that there's also a bunch of watch actions. You can tell the operator framework to wake up your controller when things happening. And in this case, for this operator, we wake up if there's pods being added to the cluster, or when our Chaos Monkey settings are changed. If they're deleted, we stop killing pods, or if they're changed, we work on that as well. Okay, so that's fairly simple. So we can run with the operator framework, we can run our operator in Minikube. You can see it starting up here in the background. And then once we have that running locally, we can do a simple Nginx deployment. And what I've done here is I created a deployment. So that's going to keep restarting the pods when they're killed. And here you can see us watching their pods. And after a while, our little Chaos Monkey kicks in, sees something nice and shiny, takes our pod and kills it. Because we're very well versed in chaos engineering. This is not a problem at all. Because we created a deployment, our deployment will take care of creating another pod for us, and all is fine again. Now, if you were to continue this, the Chaos Monkey would notice that after a while again, and then it would go and kill the pod, and then the deployment would go back up and then recreate the pod again. Now, this is the part where I said that your cluster could be in a constant state of flux. And in this case, it would be in a flux of killing pods and then waking them up so that you know that your application can survive that. We have a nice little resilient thing going on here. And now we can proceed to get funding for our startup because we stay up so nicely. We can call this that we have an AI-powered startup. Okay. So here's a little brief run-through of our operator from the control theory standpoint. Now, like I said, this is still very simple, and you could think that's quite a lot more elaborate than our little Chaos Monkey. But some of the things that we have here, they're exactly like that we had. We've got some process variables over here, desired state. And then we have a control logic that decides on the appropriate course of action. We look at the time since we had some last chaos, and we compare that to the desired chaos interval. And if it's not yet time to kill anything, we do nothing at all. If enough time has passed, but there are no pods that we could kill, we do nothing at all. If enough time has passed and there are pods, we kill them. And you can see that this little loop will actually create all kinds of funny situations, like if the monkey has had nothing to do for a while in your deployment, or maybe you put a single pod that you just want to run a job at, go and kill it immediately because it was just very bored for a while and now suddenly found something to do. The gist of it is that this is a simple loop, and you can use much more comprehensive logic to build your own loops, which do exactly the kind of things that you want. But that's pretty much it for the Chaos Monkey, to encapsulate some operational logic into programming logic in the form of an operator. Now, you may be wondering a couple of things now, so let's just do a little recap. Operators, we use them to encapsulate logic into code. We had things that we're doing when we're operating our cluster, and we've translated them into code. Operators are often a bit more elaborate than controllers. Be having multiple different controllers. Like we could, in our Chaos Monkey experiment, we could have a different controller that would be monitoring the pods that the Chaos Monkey controller is killing, and then watching and making sure that the pods come back up again. And if they don't, they would trigger some kind of alert, or maybe even stop the Chaos Monkey at that point if it's killing something that's not coming back up. Decide this based on whatever your operational needs are. We also looked at there are several ready-made operators available for popular software. There's a bunch of them, especially if you're running all kinds of enterprise versions, like Redis Enterprise has a custom operator made in the operator hub. There's obviously a lot of incentives to provide very good user experience for the enterprise versions. Probably the biggest question is, should you use them? I think you should use them if they are, or if you have them available. I mean, they can offer a lot of over building everything from simpler Kubernetes principles. But maybe the other question is, should you build your own? Something where someone might say, a wiser guru might say, it depends. You probably don't want to or even have the time to build operators for everything, and that's totally fine. I mean, there's a lot you can do with Kubernetes principles already. If a deployment gets the job done, you should probably use a deployment. If a job gets a job done, probably use a job. Much smarter. But personally, I think there's kind of like a sweet spot in not only encapsulating our operational logic, but also maybe encapsulating some good patterns on how to operate and how to do different things in your cluster, which are specific to your business case and your company. If there's a specific way that you want to do logging, for example, across the whole cluster, something that makes sense to provide as an operator in different teams, or maybe backups or whatever. Just say that if you're a startup and you spend most of your time building operators and not building your software and your product, then I think you're probably doing something very wrong. Being chewed away by repetitive operations, it's probably worth exploring if you can encapsulate and automate at least some of that hassle into an operator. All right. We got through a little bit faster than anticipated. But if you want to take a look at the operator that we built, you can actually go to my GitHub profile. Or if you're interested in what I do on a day-to-day basis, you can go check out Reaktor's website. I don't see the YouTube stream on my screen over here. If you have any questions, now is a great time to actually post them, and I will get them through the live stream Telegram that we have on the background over here. If you don't have any questions at this point, it doesn't matter. You can just ping me online. You can find me on LinkedIn. You can find me on Twitter as well, although I'm not that active over there. But shoot me Telegram on Instaspot or whatever the generation whatever's do nowadays. Thank you. And if you build operators, or go check out my operator.
everyone. I'm Mika Tuominen from Polar Squad. I'll be talking to you about Cloudrun and about that not everything has to be run on Kubernetes. Everyone, like I said, I'm Mika Tuominen from Polar Squad. I have a long history in the IT side of the things from the legacy side, and for like 6 or 7 years, focusing mostly on AWS and also on GCP nowadays, and trying to get the GCP things done properly way and on the easy way for the development side of the people. Okay, let's get started with the presentation itself. So people are not so familiar about the Cloudrun service from Google Cloud Platform. I just give you a brief introduction about what Cloudrun actually is and what it's capable of. Well, Cloudrun is a fully managed service from, and it's a Knative service, and you can run HTTP apps and services developed with any language, and it has the automatic URL and SSL cert. You don't need to think about the URLs, how to access it, and how to create the SSL certs and whatnot. And it's really easy way for the developers to start experimenting with standard containers. On Cloudrun, you only deploy containers, which are like standard industry standard containers, and because of that reason, you can use any of the languages that you want to use with the service itself. It has the capability to give you the custom domain names, but still the dynamic URL provided by Google will be there for the service itself. Combine the custom domain names with your deployed Cloudrun services in the Google Cloud Platform. Integrated capability for the logging and monitoring with the help of Stackdriver. I'm not going to talk about details about the Stackdrivers because you like deep dive to the Stackdriver and what's it capable of and whatnot. But the good thing with the Stackdriver with the Cloudrun is that you don't need to enable it in any way. It will be automatically enabled. It will listen to normal logs folders in the, for example, in the Linux-based, and also the standard ins and outs. So it will export all the basic logs from your services and from your containers. But yeah, because it's the fully managed version of Cloudrun, it's a little bit limited because it's fully managed service. Only deploy HTTP services, and the container needs to listen on port 8080, and only one virtual CPU per instance. But you can access the memory, so you have a little bit play around. And the Google will handle all the scaling. But if you end up having too little computation resources because of the CPU limitations, you might need to go check some other solutions. But let's go that in the presentation. And on the fully managed Cloudrun, because it's the services are running on Google hosted Kubernetes environment, you don't have access to your own VPC and compute engine networks, so you cannot integrate it with your, for example, and whatnot, but you can still use the like normal Google services, what you can use from the cloud. So pops up SQL databases and whatnot. So it's easy to integrate the Cloudrun services with the Google provided services. Yeah, and only stateless services on fully managed Cloudrun. So you cannot save anything on your containers, and you cannot even connect any persistent storage on your services. I'm going to only speak about the fully managed Cloudrun service. Just a few words about the Cloudrun running on GKE Anton, because if you maintain your own Kubernetes clusters on the GKE enabled, you can actually run the Cloudrun services on top of your own managed GKE Anton cluster. And what that actually gives you, it gives you more capabilities for your services. For example, you have much more configuration capabilities, how to configure the resources for your services, and they can also access your network. So then you can integrate it with your own VPC and what's running on your own VPC in the Google Cloud Platform. And when you are running your Cloudrun services on top of GK Antos clusters, you can actually then deploy your services internally only, and then they won't be having the dynamic URLs, and it won't be only like publicly accessible from the public internet. So you can only access from internally. So that also gives you more like security side of capabilities and how you can deploy your own services. And the scalability on the GK Antos Cloudrun on top of GK Antos, the scalability is limited only by your GK cluster size. But instead of in the fully managed Cloudrun, I think it was 1,000 nodes to which it can scale automatically. But yeah, so you can much more easily manage the GK Antos, and so not like having too much of the cost side, the node size and whatnot. And there's like even the option to hybrid deployments with the Antos deployment, then your Antos cluster already. Also on top of your on-prem VMware cluster, but I don't know who would be doing that because we are more or less cloud native people. Yeah, and a few words that I already said about billing, but one of the awesome feature about the fully managed Cloudrun is that the billing side. You only pay for the request processing time. So if we compare that, for example, for the app engine, you also pay about time when your services are actually idling. But on Cloudrun, even though you have the services all the time, like on a standby and idling, you don't pay anything on that time. But you only pay on that time when you have the requests coming in your service and when it spits out the response. So you only pay on that. And then when we start to use the Cloudrun on more like production type of installations, and then we will most likely use API gateway on front of that. And how the API gateway actually on Cloudrun works is that you deploy your the API gateway also as a Cloudrun service. So if you would hit any API behind the API gateway, then you get the double the billing. So it's cheap to run the services on the fully managed. And one side note about the Cloudrun billing is that the GKE management plane will be end the free tier, will stop being free on the 1st of July. So after that, you might be, if you, for example, have only for like few services running on GKE cluster, you might be migrate those to the fully managed Cloudrun. At least for the time being, Google said that the GKE Antos cluster control plane will still be free after the 1st of. That might give you the think about if you would like to migrate your GKE clusters to GKE Antos clusters. So, but you can still run the fully GKE deployments that you might be already having, and you don't no changes on that side. What Cloudrun actually is, if we think about from the dev's point of view. So normally when people start to experiment with containers, they first start with the Kubernetes clusters in a service in the managed service mode. So for example, if you are taking the GKE cluster, putting up that in the Google Cloud Platform, you still have somewhat things to be configured, set up load balancers and whatnot before you can actually get the services, your Kubernetes services up and running, and so that you can actually deploy any services in the GKE cluster. So how do I compare that to the like real world scenario? Well, I only came up with and as a child I had remote control cars. So I see the GKE more or less like a build kit if you compare that to the RC car world. So in the RC car world, if you buy the build kit, you will first need to assemble the car, get it up and right and running, install the tires and whatnot, charge the batteries and install all the electronics and whatnot until you get the driving the car and feel the experience on driving and enjoyment of the driving. That compares to the GK, because even though it's a managed service and you can get the control plane easily with just a few clicks, but until you get to the point that you have like security deployment on top of GK, you still need to do and decide about the IAM until you get to the point that you can actually deploy functional services on top of that. But what Cloudrun is actually, and why it's so easy for the developers to just start experimenting with the containers without putting the initial effort first to build up the GK clusters and whatnot. So it's more or less ready to run. So which are ready to run labeled. You go to the store, you buy the car, you charge the battery, put the battery in the car, and you are only enjoying the driving enjoyment, and you can do anything with the car. If we combine that with the Cloudrun on top of GKE Antos cluster, it's more or less like you buy the ready-to-run car, and then you can buy the upgrade parts for your car to make it better, to have more capabilities and whatnot. So that's what the Cloudrun with GKE Antos gives you. You can still run the Cloudrun from the developer point of view. You can still, even though if you deploy your services on top of GKE Antos cluster, it's still the same command that you deploy from the only one parameter more to define the GKE cluster name. But so it's to the fully managed Cloudrun. But the only difference is that you have more configuration capabilities what comes to resources and whatnot. You can access your own internal networks, and the really good thing about the Cloudrun is that because the containers that you deploy to the Cloudrun services, they are industry standardized containers. So you be using a fully managed Cloudrun. It's compatible with the Cloudrun with the GKE Antos, and it's also fully compatible with the GKE cluster. So it's easy to migrate from, for example, if you be starting on top of containers, you could easily start just by using the fully managed Cloudrun first. But then you can also migrate to the Cloudrun with the GKE Antos, or then all the way to the GKE side of the things if you want the full and how to set up the architecture for your with the load balancers and whatnot, using the Istios and whatever you want to use with your Kubernetes. But also the other way around. If you feel that your services actually isn't needing all the capabilities and all the configuration availability that you have on a GKE cluster, you can roll back and go to the, for example, for the fully managed Cloudrun, or to deploy it with the Cloudrun on top of GKE Antos cluster. So there's so much flexibility what you can do with your containers. So and the good thing is that because it's standard containers, you can do whatever way you want it. So that is basically the 3 modes of the Cloudrun service. And especially people who has some awareness around the Cloudrun, majority of people feels that the Cloudrun is more or less to run like standalone containers in fully managed environment. And yeah, basically it is the starting point where most of the people will start services and try out how you can actually deploy your own code environments. And then you can experiment easily with the containerization of your own code. For example, if you're running your code on virtual machines or app engines or some serverless functions, and you want to start to try out containerized world of the IT world of today. So it's really easy to start with the fully managed Cloudrun, and then you can do whatever you want with your containers and move on with that, and even go to the full GKE Antos clusters. But what actually enables you to let's say like production kind of use? So set up for this presentation, and the architecture drawing is shown here. So from the standalone Cloudrun services on fully managed to how to think about it, how you could use the fully managed Cloudrun in production use so that you have like more or less microarchitecture installation for your software, the capabilities of one service to invoke another service, and then extend those capabilities just by putting the API gateway in front of your APIs to, for example, enable authentication or enable like any kind of policy deployments and whatnot, and having like the API gateway URL for your all the backends and APIs, and just with the different paths to define how you can access different services behind one API gateway. The API gateway is actually also running in Cloudrun. Managed Cloudrun is also running in the Cloudrun as a service. But for that, Google actually gives you a ready-made image, which you can use. And then you only configure that with the endpoint configuration that you upload to your GCP project. And it's basically normal Swagger file where you define all the authentication and whatnot. So the API gateway gives you capability to access multiple services from one project. So, and like you can see on the architecture drawing in the demo setup, I actually have two projects. The one project is actually hosting the front end, which is also running as a fully managed. It's static website just showing the sending request to the API service and the backend service. So it's really limited. And just to point out the few different capabilities, how you can use fully managed Cloudrun is more like production kind type of use. So on the demos those. But what are cool features that the Cloudrun actually gives you, and also the API gateway, is that first of all, you can run services in fully managed mode, either wide open to the public internet or behind user authentication. So for the service authentication, you can put your services, the dynamic URL, public URL, and they have all the SSL shares and whatnot. But you cannot invoke the service. For example, in this drawing, we have the API service here in the API and API gateway project, and then we have the backend project here in the backend. The backend service in the backend project. And this backend project is actually put so that it needs to be authenticated. So I couldn't send any request on that backend service without first authenticating. And this demo setup, we have the API Cloudrun service authenticating on service, so it will be allowed to invoke the backend service and then the you. And the authentication on service to service happens actually on two levels. First of all, you need to enable, because in this setup, the API service is having its own what it's using to run the service in the Cloudrun. And for that service account, you can actually use also the normal IAM policies for SQL Server services and pops up and whatnot. But for this demo, the API service account is given invoke permissions in the backend service, but also on the API service, it needs to access first fetch the OAuth token, which is actually predefined for the service account that the API service is using. So it will only fetch the OAuth token, predefined OAuth token from the Google metadata, and then it will put up the authorization header in the request that it's sending to the backend. You need to do some code level implementation on the API service level. You don't need to do the same thing on the backend service authentication, because Cloudrun actually manages all of that for you. Except the API service account is given invoke permissions for the backend service, and after that it checks that the request actually has the authorization header and it has the valid OAuth token. And if those two aren't valid, it won't reply you back. And actually, the request won't even go to your code level. For example, if you would be having any HTTP server logging all the requests to the Stackdriver, you wouldn't see anything happening there if another service isn't valid to be invoked the other service. But think about the API gateway possibilities. With the API gateway, we can actually do it so that we can access the same Google project. And that doesn't have any, still the API gateway service account needs to have the invoker rights on the API service. But we can also enable it so that we can have the API gateway running on one Google project, and it can actually invoke Cloudrun, fully managed Cloudrun services on other projects. But on this type of setup, we only need to give the API gateway service account the invoke permissions on the service which is running on another project. So we don't need to do any code level implementation file. We don't need to do anything to fetch the token or whatnot. So I would assume that the Cloudrun image for the API gateway has all those features and capabilities. And when you enable the authentication on the Swagger file, you can actually invoke the backend service right away. So really good feature because it gives you so much flexibility, and you can have like one dev team developing their own services in their own project and deploy those to Cloudrun. But you can still have like one API gateway on one Google project. Use that to access right away to the API gateway many backend services on other projects, or then you could just create like so-called like a proxy service in the same project that you are running your API gateway on, and that would need to fetch the OAuth token before it actually sends the HTTP request on the service which is running on another project, and so on and so on. And yeah, the front end isn't behind the API gateway; it's just a standalone Cloudrun service and static website, like I previously mentioned. And on the demo setup, I have the API service and the backend service both are written in Golang. And actually, one good feature in using the Golang is that they are really, really fast to start on the Cloudrun on any other languages. But for example, if we would have like this kind of cold start situation, even though it isn't like totally cold start because the container is already there running, but for example, when I was developing these demo setups, and I had like made some changes on like on the afternoon, and then I came back on the following day to continue the development, and I first hit the refresh button on my browser. Almost like any difference when it was for the cold start situation for the front end or the API service or whatnot. So fast on starting even on those cold start situations. And yeah, like I already mentioned, the API gateway is actually based in normal Swagger file, but Google only has added some their own parameters in it, which will enable for example, API key authentication and Firebase authentication and whatnot. And you can have like the multiple backend definements using the Google provided parameters in the Swagger file. But more or less the other ways, it's basic Swagger file. And I think there are a lot of backend and front-end developers who are familiar with the Swagger format. So it's easy to even start with the API gateway deployments. And Cloudrun, even on the fully managed Cloudrun environment, you can use it more also in the production use and not need to go to the GK clusters, putting up those before you go to the production. So really flexible, and you can do a lot of things with it. Yeah, if you couldn't see the architecture on the small picture, so I just have it here. So let's now jump to the demo, which isn't actually that brief of a demo, but still giving you some ideas how the thing actually works. Demo purposes, I have two projects. One is the demo Cloudrun which is hosting the front end, the API gateway, and the API service itself. Then I have a backend project, has the backend service here running. And if we go to the front end side, the front end is actually trying to mimic some of the how we can actually invoke. First of all, the first request with the API is meaning that it's hitting the API gateway first. API is actually going to the API service itself. So the request on the first setup is coming from through the API gateway and going to the API. So and use that, and it's actually just fetching some ad hoc information to throw no any valid information, but that reply is coming through the API gateway. The API service actually is behind authentication, so it doesn't allow unauthenticated accesses. Try to access that. Oh, sorry, I have wrong deployment here. They're running, but it should have been behind the authentication. But sorry, yeah. When we access it through the API gateway, it is valid. And now if we try to, this is the same API service running and having the about. Sorry, I should have removed the first example. But then when we go to the situation that we actually will end. So in the last setup, we use the front end, and there's two scenarios. We go through the API gateway and we go to the API. And then there's another scenario where we go first to the API gateway and then we go to the backend side and get the reply from there. So this, when I click to get about, it will actually send the request to the, send the request to the backend through the API service running on the same account, but it's actually failing. Haven't enabled for the API gateway. We get the forbidden message. Well, this wasn't the demo issue. I just wanted to show you that what it's there needed to be make the configuration to enable the access to the backend through the API gateway. All API cloud write fi/backend. It's going through the API gateway, and it's actually going through the right away from the API gateway to the backend service. So use the GitHub Actions as a CI/CD pipeline, which is also, I could mention that it's really easy and fast way to start your CI/CD deployments. And there's no, even though the Cloudrun services are really easy to deploy, because after you have built your container, it's only like one command to deploy the actual service. But still, it's easy to and it's good practices to put everything on the CI/CD pipeline, so it's easy to run those like many times. So let's try to activate the invoke for the API gateway to the end service. So let's see how long that will take, but long. And while it's actually deploying that, I can show you how you can easily find out the access to invoke your services if you have service-to-service authentication on. So now we are in the backend service project, and we are looking about the backend service. And when we go to the permissions, all the permissions who has the Cloudrun invoker permissions for your service. And like we can see, the Cloudrun API service here, that's the API services service account still has the invoker right, but the API gateway actually doesn't have those capabilities because it's missing here. See if GitHub Actions has already, it just jumped in, but it's still deploying the actual deployment. Yeah, it's configuring the Docker, pushing the image. It should be here fairly shortly. So an API now currently has the invoker rights, but the API gateway doesn't. And until we wait that the deployment is done, we can go actually see and see about on the console how you can manage the different services and whatnot. So every time you actually deploy a new Cloudrun service, it will create a new revision for it. And you also all the time you actually see all the revisions for your service. And what's really cool feature about this, for example, if you new version of your service, which is actually in some way it doesn't function, you bug, really bad bug, you can actually really easy to manage your traffics because you can only you just select the older revision of your service, and then you can select how many of the percentage of the traffic will be directed there, or you can just put all the traffic to go into the old service version of your service. And here you can see the basic configuration related to your how much memory it has, then up to 1,000 containers, and then there you have the link for the container image, which is actually on the GCR repository. And here you can actually see the Cloudrun, the service account that the Cloudrun service is actually using. Account you can use for normal IAM purposes to give it more or less permissions on the Google services and whatnot. So let's see if the API gateway now has the invoke the backend service through the API gateway. And now we have seen that the GitHub Actions the pipeline has added the invoke permissions for the API gateway service account. So when we now go here and we update this, now it's going through. So in this setup, the request is going through the API gateway and to the backend. And before the refresh, I had removed the API gateway service account, the invoker right on here on the backend service. So that was the reason why it gave the forbidden message. But now it's capable of invoking the backend service. So from the backend service through the API gateway and show that in the front end. Like mentioned, all the services have their dynamic URLs deployed. And because I have actually used the custom domain naming, the URL on the console will be like not activated. It will be grayed out, and you cannot click that. But when I access that through the mapped domain name, so this is trying to, when I click this URL, in this case, it needs to be forbidden because actually the situation goes so that I'm now actually trying right away access the backend service and not throughout the API gateway. And naturally, because the backend service wasn't open up to the world, so it has the. It's funny that the authentication actually shows if it's allow unauthenticated, but if it's behind the authentication, it doesn't actually show it here. So that's something that you just need to know. And if I still show about if we think about the situation that we have a service account accessing another one service accessing another service, like I mentioned previously, you still need on the service account level, you still need the invoker permissions from service to the service that it's trying to invoke. But also on the code level side, on the service that is sending the HTTP request, you need to get the OAuth token. And in the Golang example, it's fairly easy to do that. Google actually provides you the examples and how you can actually enable that. So let's go to the Golang implementation of the API service. Like I mentioned, the API service is actually invoking the backend service. So this is actually only thing that it needs to be done. So here is actually fetching from the Google metadata the token, so metadata get token URL, and then it's implementing that in the authorization header as an ID token. So, and then it's just sending the HTTP request. So that's all that it's needed to enable the service-to-service authentication happening between two services. So the API service has the invoker right on the backend service, but also it needs to inject the OAuth token in the headers of the HTTP request. And yeah, and that actually ends my actual demonstration, but we can still go on and look about the console, and you can see actually in the console. And like mentioned previously, you actually have all the logging enabled in the services by default, and you don't need to configure that in any way. Just be sure that for example, on the standard out, you use that output anything. You can have a brief look on the logging on the Cloudrun console part on the GCP console, but then you can still go on and look those in the actual Stackdriver logs. But yeah, it gives you basic information about when someone was invoking a service, and if you would hit up any errors, you could see those in here. But yeah, I think that is mainly my part of the demo and the introduction about the Cloudrun, and especially about the fully managed Cloudrun service. So like mentioned, there's 3 different setups for the Cloudrun. Then you can run the Cloudrun on a GK Anthos, and naturally you can just go on and use the same containers on the GK clusters. But this more or less to demonstrate that even though the fully managed Cloudrun can be seen more or less like a standalone services running on Knative environments, it still has quite many features and capabilities. And if we could still briefly show you the Swagger file on the we can actually, if I can just find it, template file, which I actually then, because we need to fetch the URLs for the backend services and for the API gateway, so I use template, and which we then build on the Docker building phases. But it's normal default Swagger file configuration, but then Google has added some parameters here. So for example, we can define the root level the backend addresses, but then we can still add on a path level a different backend services. For example, the API gateway now is default routing all the requests to the API service, which is running on the same project. But at the same time, I enabled it so that we can actually access the backend project on another backend service on another GCP project through the same API gateway. And we just define the Google backend parameter here under this one path, and then we can access that. And I don't have that for this demonstration, but the API gateway that Google provides you for the Cloudrun services, it has the capabilities to put up the Firebase authentication. So, and this is what you actually need to do for the Firebase authentication. First of all, you need to have the Firebase project up and running and functioning, but then you just need to fetch some of the tokens and whatnot and put it in the Firebase authentication. And then you can define on the path level which paths are behind, for example, Firebase authentication. And at the same time, that gives you the flexibility. So you can have different paths behind the same API gateway having different security scenarios. So you could, for example, have API key authentication on one path behind the API gateway, and one path would be having for example, the Firebase authentication. And that way you can get the information on your service side that who is the person actually accessing your services from the front-end side or whatnot. So also the Firebase authentication is really easy. So that's also one cool factor about the fully managed Cloudrun, and when you use the API gateway in front of your Cloudrun services. But I think that ends up my presentation and my demo setup. Yeah, the demo was brief, but I think I hope that that showed you on some level that even though the fully managed Cloudrun can be seen more or less like a standalone service, it has so many bells and whistles. And the main thing is that, especially for developers who are just starting out testing containers, it's damn easy just to deploy. Build your container and one command to deploy it to the Cloudrun as a service, and that's all you need. The Google will handle the URL creation, the certificate creation. So, and then you can add more bells and whistles and capabilities with the API gateway. And when you start to fiddle with the service authentication, splitting your services in many different projects. So you have you can have easily different development teams maintaining their own project, but still have the consolidated API gateway and have another services accessing another services, and the both services are developed with different development teams. I think we have one question. For the Iironiemi is asking on the chat that is the code for this Cloudrun demo available somewhere. Currently, actually, it isn't. The only missing part is the documentation, naturally. Every time the hardest part, but yeah, I think we can post that on the meetup information later on. And yeah, I can provide, because there's no project related stuff going on the code. So it's, yeah, I can briefly go through the repo. So we have the API and the gateway folders, and then we have 3 different pipeline configuration files. So it's quite that simple. So yeah, I will take a lead on that, and I will open that repository for you for the later on to fetch it. And I hope we can message that to you on later on through the meetup. Yeah, but thanks for my part. I think this was enough for me. And if there isn't any more questions, so. And even though we are having hard times in the society and whatnot, it's really good that we can actually still continue with our work and share our knowledge and get everyone involved. So thanks on my behalf. And I now think that from our side, Tero still has some the meetup and for the people. So I now hand over my part, and thanks.
Thanks a lot, Anton, Lauri, Mika, for doing a spot here. And thanks for everyone who joined us today on the live stream. And if you are watching this as a recording afterwards, well, that's great also. You are great. I've got nothing further to say, but stay safe and have a interesting and pleasant spring. Bye.